Now we're going to look at geometric probability. Very similar to the probability we've done so far, where we talk about the number of successes over your total number. The only difference is now we're going to go back to some geometry stuff and we're going to talk about area. Well, the first thing we have to figure out is our total area. Let's say that this was a game at a carnival and the area was a 10 by 8 foot square rectangle, and you get certain points for landing in one of the two circles when you throw your ball. Well, the first thing I would have to do is multiply the 10 times the 8 and find out that my entire area, and we'll just say this is feet, is 80 feet squared. That is the entire rectangle. Well, now, let's say that I'm looking at this circle right here. If you land it in here, you get 1 point. I want to find the area of that circle. Well, we know the area of a circle is pi r squared. So for this circle, I'm going to do pi 3 squared, which is 9. It's going to give me an area of 28.27. Ran out of room here, feet squared. Let's say this is a 2-point circle. I get 2 points if the ball lands in here. I'm going to do the exact same thing. And I end up with 12.57 feet squared. Now I have the area of success. I have the area for the 2-point circle, and I have the area for the 3-point circle. So now what I'm going to do is, if I want to find the area or the probability of landing in the 2-point circle, my area of success would be the 12.75 divided by your total area, and I would find this to be 0.16. So the probability that I'm going to end up scoring in that circle is 0.16. I would do the exact same thing for the 28.7. If I took my 28.27 divided by 80, again the area of success, divided by your total area, I'm going to get 0.35. So the probability of me landing in the 1-point circle is 0.35. If I added these two together, I would get 0.51, which means the probability of not landing in one of those two circles would be 1 minus the 0.51. So the probability that I do not score any points would be 0.49. All you have to do in a geometric probability is go through each piece, find the areas, and then follow this idea down here. Area of success equals total area. Let's look at another example. In this example, what I'm looking at now is I have a big board, and to find the area of that big board, it would just simply be the 10 times 10. And now I'm going to get certain points based on which square or which rectangle I fall into. Well, I'm going to find the area of the 6 by 8 rectangle. But here's the thing now. If I want to find the area of what's in here, this goes back to that area of a shaded region that you talked about way back in geometry. Well, I'd actually have to take the 100, subtract 48, and get 52. That's the area that I highlighted in red. Well, now I'm going to go back, and I'm going to look for the area of the small rectangle, the 5 by 2 rectangle, and that has an area of 10. Now, if I want to go through and find the area of this section that I'm highlighting in orange, we know it's 48, but I have to take that 10 out. So that means I have 38. So the probability in this case is all going to be based on that 100 that we found to be the overall size. That's my total area. If I want to find the probability, then I'm going to end up in the red section, which we'll call the large section. It's going to have to be 52 divided by 100, which is 0.52. That's the area, that's the probability of me landing inside the red section. What's the probability of me landing inside the orange section? So we'll call that my middle section. Well, the area in orange is 38 divided by 100. It's 0.38. The probability that I'll land in that orange area is 0.38. Well then, since I have no pieces taken out of that middle section, which I'll highlight in green real quick, the probability that I end up in the small section or the innermost section would just be 10 out of 100 or 0.10. So in this case, all my answers here, here, and here, that's the probability that I'm going to end up in any of these three sections. If this was a carnival game, and we found that, for example, you got a certain amount of points like we did in the last example, you'd be able to use this to figure out the expected point totals.